All right, this is part 2 of the 4.8 notes. We're going to go through examples 2 and 3, and that should help you do problem number 8 on your homework. I think this should hopefully be review. So a point on level ground 125 feet from the base of a tower. The angle of elevation is 57.2 degrees. Approximate the height of the tower. So I want to know A, which is opposite of the angle that I'm given, and I know that 125 is adjacent. So I'm going to set up the trig function that uses opposite and adjacent, which is tangent of 57.2 degrees is equal to A over 125. So when I multiply both sides by 125, it'll give me my answer. So the first thing I'm going to do is make sure that I'm in degree mode, which I am, and then I'm going to take 125 times the tangent of 57.2 to get my answer of, let's see, rounded to the nearest foot, that would be 194 feet. Okay, so moving right along, you can pause the video and then practice this problem, and then we'll come together for our answer. So if this, let's see, is this this is going to be the Eiffel Tower. I'm not going to try any harder than that. And they say that I'm 80 feet away, and I'm looking up at the Eiffel Tower. My angle of elevation is 85.4 degrees. And they say, what is the height of the Eiffel Tower? So again, I'm looking for opposite and given adjacent. And so I'm going to set up that the tangent of 85.4 is equal to opposite, so x over adjacent, which is 80. When I multiply both sides by 80, I'm going to get, oh, that is not what I meant to do. I'm going to take 80 times the tangent of 85.4 to get, they don't tell me, rounded to the nearest, we'll just do nearest foot, 994 feet. And so just because I can, I Googled how tall is the Eiffel Tower. It says 984 feet, which is pretty close. So this math could have been a little more accurate, but it's still okay. All right, so number 3, a kite flies at a height of 30 feet when 65 feet of string is out. If the string is in a straight line, find the angle that it makes with the ground. So I want to know what that angle is. So let's see. Based on this angle, I know the opposite and I know the hypotenuse. And so how I find the angle is I set up, well, opposite and hypotenuse is sine. So I'm going to set up the sine of angle A. And I can call it theta if that's what I'm used to. But the sine of the angle is equal to opposite, which is 30, over hypotenuse, which is 65. And how I'm going to find the angle is I'm going to take the sine inverse, because the sine inverse and the sine are going to cancel. So when I do sine inverse of 30 over 65, so when I type that into my calculator, I will get angle A. So angle A is equal to, when I take sine inverse, which is right above the sine key, so sine inverse, I have to hit second first, of 30 divided by 65. It says round to the nearest degree, so I would call this 27 degrees. So pause the video, try this practice problem, and then we'll get the right answer. So a guy wire is 13.8 yards long and is attached from the ground to a pole 6.7 yards above the ground. So here's my pole. If it's attached to the pole, then that pole is 6.7 yards, and then the wire is 13.8 yards long, and it is attached from the ground. So that means this here is 13.8 yards. And so this makes a right angle. They say find the angle to the nearest tenth of a degree that the wire makes with the ground. So now I'm worried. Oh, it did say nearest degree down there, up there, and now we're doing nearest tenth of a degree. So make sure you read the instructions and you round to what it's asking you for. So I'll call it A, you can call it theta, you can call it whatever you want. So I'm going to, because I know opposite and hypotenuse, say that the sine of A is equal to 6.7 over 13.8, and I'm going to do sine inverse of both sides. So when I do sine inverse of 6.7 over 13.8, it's going to tell me the answer. So sine inverse of 6.7 divided by 13.8 tells me that this angle measured to the nearest tenth of a degree would be 29.0. Okay, those were interesting instructions. That's just 29 degrees. So you are now able to do number 8 on your homework.